Hey guys, Technivorous here. You have found my unboxing video for the Anet ET4. In just a moment we're going to unbox this bad boy, open it up, take a look at all the parts and pieces, and we will assemble it and get our first print going. Now, this printer is pretty advanced, especially for an Anet. It has a lot of bells and whistles that most other printers don't come with in this price range, and I am very, very excited to open it up and get to play around with it. We'll get the box popped here, get rid of that logo, and here we go. Very pretty and shiny. As you can see, some of the pieces are a little bit jumbled. Now, Anet, when they send me printers for review, they're sending me printers that other people return. Generally, they send me 2 versions of each, hoping that one works. So, not the best policy for getting reviews because, you know, if it's returned, it's probably already broken. But we'll put this together, and between the two, should be able to get one decent machine. This is the hot end here. It is very Ender 3-like. The main difference between this and the Ender 3 hot end is the actual heat break and radiator itself. We'll go ahead and set aside some of these pieces. That white piece you see is actually a model that was printed by the previous owner of this printer, and for some reason they threw it in the box with the printer when returning it. Let's get this out and get a good look at the base underneath. The base is one of the most interesting parts of this unit. Other than the base, it is almost identical to the Ender 3, but with some additional add-ons. And get this out of the way here. And there you have it. This is the bed for the Anet ET4. It is a very, very stable Y-axis system. Take it out and get a better look here. They also send a build surface. I did try a print with the build surface attached, but it is a sticky back build tack surface. So I basically just slid it under the glass clips on top of the glass to test out the adhesion of the surface. But I didn't actually adhere it to the bed because the glass is working really well on this machine so far. And we'll move this out of the way. We'll come back. We'll get this box out of the way here. Oh, what's in here? That little slot right there with the styrofoam top on it that I'm pulling off, that is the power cord. We will take that out, as well as the leveling sensor, which is this little green guy here. And basically that's going to clip to the hot end and cover the nozzle, and it'll be used for the auto bed leveling. It's pretty simple, straightforward. We won't be covering that in this video, but we will cover it in the review video that is coming up. And let's get this out of the way here. Sorry about the pulsing. It's trying to focus and it's got nothing to focus on. So here we go. Get back in view here. I'm going to go ahead and slide this to the back here. It's actually going to end up coming out of a hole back there eventually, but for right now, we're just going to kind of make sure that we have all the pieces according to the book and make sure that everything is where we need it. So first thing we're going to do is come over with the gantry here because we need to screw the Z-axis to the base. Now, it's a very simple printer assembly. Basically, assembly is just 4 screws. You can see the 4 screw holes in the base of the Anet here on both sides of the bed. So we're going to need to flip over the base unit here, get it up on its side. We are going to put the already assembled X gantry onto here. And we're basically going to line it up and slide the machine screws in through the bottom here. What we will do is pull the beam a little bit away from the base, make sure that the machine screw goes into the hole, tighten it down a little bit, and then we will leave it as we adjust the others. We will tighten all 4 at the same time once they are lined up. So now we're going to go over, we're going to do the other side and make it a little bit more stable. And as I said, this is the main part of the assembly of this printer. 4 machine screws through the bottom into the gantry, into the Z-axis in order to hold it steady. And because of this base being so solid, there is really no bracing required on the front and back. So here we get a little bit better view of the bottom. Most of the electronics in this unit are not exposed. They're under this little panel here, and underneath this panel is the power unit, the LCD display, a couple other things. There is a sticker on it that will void the warranty if you remove the sticker. I've already taken both of mine off and opened both of the power cases to double check the connections because unfortunately Anet is notorious for poorly connected motherboards and things like that. These machines were both actually really, really well done. I did have one problem with one of the machines not wanting to turn on unless it was tilted to a certain angle. I posted a video about that. I can put a link to it up here in the corner, and you're welcome to check that out. But I am pretty sure that that doesn't reflect all of these machines. As I said, the machines they send me to review are usually review machines. So you expect there to be a couple little problems. The awesome thing is that 9 times out of 10, I can get them working, and it's actually the tinkering and adjusting that I think I enjoy almost as much as the printing. So here we are tightening these screws down as tight as they'll go. We'll go ahead and just pull this cord out so it's out of the way. And there is another slot here underneath my hand basically to feed out this braided cord. That's going to attach to the X motor. We'll go over that in just a minute. Get these guys nice and tight here. Obviously, you want to be careful while you're doing this. I am holding the machine steady as I'm screwing the machine screws into it, and you want to make sure that you are on a level and stable surface because you don't want to drop the machine or knock it over and bust a piece off before you even get to print with it. That would be a tragedy. So go ahead and tighten these guys down. Almost done with this part of the process here. And as soon as we finish this last bolt here, we can flip it over and see how it looks. First, I want to feed this here through the side slot I was telling you about. Like I said, it was covered with my hand. Actually, let's just wrap it around real quick so we can flip it over and make sure everything else is properly connected. Now, my initial thought was that this piece connected to the bed, which is why I pulled it out the back like that. I was not really aware that this is the way that this works. So while I just pulled that cord over it, I actually crossed them. That's the bed cable, and we're going to hook that into the bed. And you can see I'm just noticing this just now. So, nope, flip it over. There you go. All right, so we're going to pop the bed on. This is the first connection we've actually made on this machine, and the second step. We'll go ahead and connect this as well. So this is the second connection we'll make on this machine. And the third step, we'll deal with that in a second here. I really like the look of this machine. I really like the red. Okay, here you see the hot end, and this is more evidence that it was returned. The hot end was returned with filament still in it. So that's frustrating, but it wasn't really an issue. It did heat up, pull right out, so we're going to go ahead and just basically another printed fan shroud. They're notorious for printing any part that they can. This machine actually has the fewest printed parts on any Anet that I've seen. That is basically the only printed part on there is that fan shroud. So this piece basically just rolls right over the X gantry. Okay, and this is what's known as your carriage. So we're going to feed these back under and through into the back of the machine, because back there is where the Bowden is attached and where we are going to plug in all of our sensors. Now, you heard me mention that this machine has a lot of bells and whistles, and I did already say something about the automatic bed leveling. That little tabby there that's floating around that I just grabbed, that is where you connect the automatic bed leveling sensors. Basically, it's a 2-pronged plug, and when you're ready to level the bed, you will plug right into there, and then you will put the sensor on top of the nozzle, which, by the way, needs to be below 50 degrees Celsius, just so you know. And then you'll hit auto home, and it will home. So I do have another Easy Able sensor kit here. This is not the same thing. I'll show you. This is a little bit different. It doesn't have the right cables and stuff like that. So this is going to go on one of my other machines. But this is basically similar to what the sensor on this machine is, except it is removable. It's not a hardware edition. So we're going to go ahead and grab some of these plugs. You see quite a few plugs here, and the reason for that is there is a leveler plug, a hot end plug, a thermistor plug. There is the 2 fan plugs, as well as, here you can see a little bit better, the end stop plugs, and things like that. So I'm going to go ahead and feed the Bowden into the coupler here. And in doing that, it forced the filament out the back. Obviously, it's not going to go back through one of the other bells and whistles here, which is the filament runout sensor that is equipped on here. And, oh, yeah, actually, now that I think about it, I may have fibbed to you. That part is actually printed too. And we're going to go ahead and connect it right now. Inside the filament runout sensor, there's basically another limit switch. So when the filament is inserted in there, it presses the limit switch. And once it pulls past that point, the switch pops back out and will tell you that you're out of filament. So we're just going to kind of double check our connections here. Everything on this hot end is pretty well labeled. You can see the white sticker towards the end of the clip. That will tell you what part it is here. And basically, it's labeled on the board as well. There's a mini board here. We are going to plug that into the corresponding slot. Now, I'm trying to show the lettering here, but because of the lighting and the focus of my camera, it's hard to see. It does say quite clearly what it is, and it has the matching label on the X board as well. So, pretty simple to do. Those are the most intensive connections that we have. Once that's done, we have a few more steps to run over before we can fire this guy up. Here you see that leveling sensor I was talking about. It's pretty simple to install. Basically, you're going to attach it to this 2-pin clip here, and then you're going to roll it under the hot end and encompass the actual nozzle itself with this styrofoam piece here. Again, you want to make sure your hot end's under 50 degrees Celsius. Also included in the kit was the obviously mandatory USB stick. There is a micro SD card in there, and that is going to contain your software and your first initial test files. So now that we've got everything all hooked up, let's take a look here and try this sensor just to get a good look at it. As I said, you're going to hook it into that clip there, and then you're going to basically fold it over the hot end here, and you're going to clip it right onto the nozzle. So it's basically going to look like that when it's installed, and at this point you can hit the auto leveling sequence. You're going to want to make sure that you do hand level without the sensor on first to make sure that you are pretty close to where you want to be. So basically what happens is as it hits the bed, it pushes together a little button in there that lets it know that it's reached the plate. So it moves real slowly. It's going to tap down, hit that sensor, and then it's going to raise up a little bit and move down in tiny increments so we can get a more exact measurement. So we'll go ahead and take this off. I will show you how to run the auto leveling system in a separate video later on. We're going to go ahead and make sure that we put the clip cover back onto those clips because we don't want it filling with ground up filament or dust or anything like that. So that is basically the gist of that. The final part of the assembly process is going to be attaching the spool holder. And it is a fairly simple spool holder. It is basically a piece of pipe with 3 screwing ends on it. And I'm going to remove this piece on the end here. And I'm going to place the sheet metal plate in between those 2 pieces and screw the cap back down onto it, which leads to a very stable right angle for the spool. So once this is tightened down, be aware that you can tighten both of these other parts or loosen them in order to increase or decrease the size of the spool that it is intended to hold. As you see here, I can unscrew that, widen it up a little bit, and I can also unscrew and screw the other side to widen that as well. So we're going to grab a couple more of the bolts that go into the frame here. We are going to slide them in, and then we are going to put, well, maybe I'll just throw it over there in the corner. Okay, so pop it in. It doesn't go in this time. There it goes. And we will put them both in. I'm going to use my fingers to hold them both in place while I screw the locking nuts slightly onto the back, just enough to keep them in place while I fit them into the slot. You want to make sure that they're oriented the proper way, which means the side with the 2 right angles is facing the bolt, and the angled side of the nut is away from the bolt. So that's going to ensure that it fits into the groove properly, and when you tighten it down, it locks to the frame. You can do that with both pieces. We will make sure they are turned to be somewhat straight so they slide into the groove a little bit easier. And if I remember correctly, once I slid this in, I did move it a little bit and make a couple adjustments. At first, I slid it in kind of to the right of those 2 machine screws up there, and I wasn't happy with the position, so what I ended up doing was moving it over so one of these bolts and nuts was in between the actual machine screws that hold the gantry there. So let's grab the other pieces that I need over here. I'm just kind of fiddling with it off camera and making a couple of adjustments to get those bolts right where I want them. We'll line them up, and then we will pop it onto the frame. Once this is done, we will be ready to begin our print process. We are going to start a test print. It'll be one of the ones that is on the test file. So as you can see here, I did place it over a little bit. And the placement of this spool is actually, pretty ideal. It is directly above the filament sensor, basically, where it's going to pass through the runout sensor that you see down below and then into the extruder. And the extruder is a Bowden type extruder, and it is mounted to the x-axis, so it moves up and down as the X gantry raises up and down on the Z. So I did end up changing the position of that spool holder, as I said. We're going to take it off and move it over just a little bit to the left. But for now, we are going to take a look at the belt on the y-axis and make sure that it is properly tensioned. Now, this is a different kind of tensioner than you're used to seeing. It doesn't put tension on the pulley. What you're doing here is using the motor mount itself as a tensioner. So in order to increase tension on this, oh yeah, I almost forgot about this. This is what runs all the hardware to the X end. So this is the basically going to connect the board for the X-axis to the main board itself. And it is a pretty simple clip. It's basically going to slide into this little opening here, and you'll hear it click in when it is properly inserted because there are two flanges on each side that click and hold it in place. So go ahead and install this guy. And pretty self-explanatory. There's only one place that fits, and it does fit pretty snugly. All you have to do is pop it in and clip both of the tabs closed, and you are ready to go. Raise the gantry up here, and we will give it a little turn so we can get a better sight of that Y motor. The end stop on the Z motor is not, or excuse me, the Z motor itself isn't plugged in, and we will plug that in as well. I know I've said this already, but I believe this is the last actual connection that I make. But just while you have a good view of the y-axis, the motor is underneath in the case, and there are two pulleys right next to it. And basically, you're going to unscrew those 4 bolts around the motor and slide it back until the belt is tensioned, and then you're going to bolt them back down. It is the same, actually, on the x-axis. If you look, the pulley on the lower side in the picture of the x-axis doesn't have a tensioner on it. It is just a pulley. The tensioner is, again, on the motor side. So it is pretty simple to adjust, pretty straightforward, doesn't lead to many problems. Now that I got this all hooked up, we have all our cables. I'm just checking connections, making sure everything's properly plugged in. And one of the few things that I didn't have to do on this machine, but you're going to want to do on your machine if you get a brand new machine that is right out of the box, is to check the eccentric nuts on the wheels on both the gantry, the X carriage, and the Y-axis as well, just to make sure that they are tightened and you don't have any play in there or looseness. Mine were riding pretty smooth, so I left them how they were. This is the initial firing. You can see I turned it on. You can barely see the color on the screen there. I will show you a little bit better view of the screen here in a moment. You can kind of see it through my phone here. I do have that video, and I will upload that when we do a review, because we're going to be reviewing a lot of the software as well as the actual hardware of the printer. Now, if you look at this machine, it looks a lot like an Ender 3 that has some red components and a more sturdy base, I should say. This printer retails for about $200 to $250, depending on where you're getting it at. So same size as the Ender 3, a couple more features than the Ender 3, a little bit more stability than the Ender 3. What's basically going to be the main selling point of this printer is the print quality. So let's see if it can hold up to the Ender 3 when it comes to printing an actual print. We need to install the belts. The only belt that is not attached is the X belt. and I will show you how to do that now. Basically, what you're going to do is you're going to take it and insert it with the grooves of the belt down through the top of the X carriage. It's going to slide into the V slot and right under those wheels. And you can see that kind of in both these angles here. What you're going to do is pull it around the motor here. And as I said, the tensioner is on the motor side. So if you haven't already, you're going to want to loosen the motor a little bit and ensure that it actually fits properly. And then tighten it down once you have the belt secured. Otherwise, you're not going to be able to reach all the way to the belt side. So put in one side to keep it from slipping out there. Then we're going to have to hold the gantry still, wrap it around this pulley, or excuse me, hold the carriage still, wrap it around this pulley, and basically slide this into the other belt slot over here. You want to make sure that we keep it on both pulleys. Sorry, I kind of pulled it out of view here. I was trying my best to get good angles for you guys in these videos because I know in the past they've been slightly lackluster. I think we're doing a lot better job here, but I was also pulling on it quite hard. So we got that other part of the belt installed, and now we are going to pull on the motor here and put that tension that we need on the belt and tighten the bolts down so it doesn't go anywhere and keeps the belt taut. So just a couple more turns of the Allen key here to ensure that everything is snug and tight. Give it a quick once over. And here we are. This is the machine fully assembled and ready to go. It is pretty simple assembly process. And now we are going to go ahead and get our micro SD card out. We're going to insert it into the printer and go ahead and print one of their test files. One of the caveats with this machine, my biggest complaint about this machine from the initial build, firing up and startup, is that when you insert the SD card, it does not reread the card. You cannot reload the card. You have to turn off the machine and then turn the machine back on, and it will read the card on reboot. So as you can see, I stuck it in here and it wasn't reading any files. What I had to do was turn the machine off, turn it back on, and then it finally registered. So I'm just checking a couple of the cables here to make sure they don't get caught. You can see that Y cable has actually gotten caught twice now on the V-slot bar as the bed was going back. So I'm going to need to do something about some cable management there. I think some sort of zip tie towards that corner should do just fine. I'm going to fetch some filament here. Looks like I have selected some MG Chemicals green PLA. Now this is a translucent green, but it's one of my favorite greens. If I could have a Technivorous green, it would be this color. So getting the spool ready here, and we're going to put it on the machine. We're going to pass it through the filament runout sensor. We're going to pass it into the extruder, and we are going to push it all the way down the Bowden tube until it reaches the hot end. This is pretty straightforward. It is exactly the same as loading an Ender 3 with the added step of passing through that runout filter. And pretty simple. You're going to want to cut the tip of your filament into a 45-degree angle, feed it in there. After I heated mine, I had to pull the old white spool of filament. So that's why you see some white coming out as I'm pushing the green in there. It's starting to come out slightly green, and we are good to go. So we'll come back to the front of the machine, see if we can get it to print. If I remember correctly, I still haven't found the file. At this point, I hadn't realized that I needed to turn it off and then turn it back on. We are going to send the bed to leveling position. So first thing it's going to do is home, which, as I said, it homes to the back and top. And then it is going to lower down to the bed. The head will at first rest just in the middle until you pick a corner. The bed leveling system gives you an option of touching the four corners, and it will automatically place the head directly over the screw that you're trying to adjust. So we're going to slide some paper in here and get to the leveling process. Now, doesn't matter how level the printer looks, you're always going to want to do this before your first print and in between every couple of prints to ensure that it is remaining level. prying on the bed, knocking models off the bed, putting downward pressure on the bed, things like that all make minute changes, so over time they add up and your bed will become uncalibrated. Basically, you need to go back, make a couple adjustments to the screws, and then rerun the auto leveling system. Now, I will say the auto leveling system is an amazing addition for a printer this cheap. It works really, really well, and so far I am really enjoying it, but it is not absolutely necessary. Running the paper leveling method and then just starting your print is perfectly acceptable and will get you close enough to the accuracy that you need for bed adhesion. Using that automated system is just a little bit of icing on the cake, and like I said, for a printer that's this cheap, the auto leveling system being included at all is pretty amazing, coupled with the fact that you also get a filament runout sensor and you also get an LCD touchscreen. Now, the LCD touchscreen is one of the major selling points of this printer, and it is one of the reasons I was so excited to try this printer. I am sick of clicky knobs and reset buttons. They're quite annoying, and finally, we are going to get ready to fire this machine up. Now, when I do finally start the print, you'll notice that there is no sound. That is because I have sped the video up. I didn't want to sit here and make this video 3 hours long. There is a little bit of print time included, so you can see the machine working, and then we will discuss the models. But you should know that this is hands down the quietest stock machine I have ever received. In fact, the motors are so quiet, and it running on wheels makes it even quieter, that you hear some strange noises sometimes, such as the belts creaking and things like that. At first, this was a little disturbing to me, but then I realized most of these printers probably make that noise. You just can't hear it over the noise of the motors or the linear drives. So, pretty amazing printer for the price point. And I know I'm kind of raving about it a little bit. Don't take my opinion just yet. Like I said, we got a couple of weeks of testing before we do an actual review for this printer. But I will say that so far I am thoroughly enjoying using it. And you get a nice shot of my back here while I level out the printer. You can see my bald spot and all my dandruff up there. That's great. No. Basically going to do this corner here, make that adjustment. We'll do the final corner. We are super close to getting ready to print. So if you've stayed with me for this long, please bear with me another 10-15 minutes. We will get this video all wrapped up. I'm very, very excited to play around with this guy. And in fact, as I said, they sent me two. I have one of them up and running. The other one has that interesting power problem we were talking about, but I hope to have that up and running by the end of the day as well. I just had to do some editing and stuff first so we can get a video up. On a side note, you may have seen the Guess That Printer game we were playing, where I showed you the Anet A8 Plus you see to the left of the ET4 here. They also sent me two of those machines. Going to be a little while before we do any videos on that because I'm still adjusting it. Not really happy with it at the moment, but like I said, we will give it some time and make those adjustments before we give it a review too, just to be fair. So we are looking pretty good here. I was curious about this PEI sheet I had to see if it was the same size as the glass, but it's a little too large and I'm not quite wanting to cut it yet. So we're going to run our first print on glass. And here you have the moment where I realized that there are no models on the SD card. There are, but it won't show them until I reboot the machine. So we are going to, first I tried popping the card out, popping it back in, see if that would reset it. That did nothing. So I'm pulling the card over to put it on my PC here and ensure that there are actually files on it, and there were. So no problem there. I did finally get it put back in, turn the machine off and on, and started it up, and we are ready to print here. So you can see making a couple other minor adjustments, making sure that my camera is recording, making sure I have the angles that I want and things like that. So come back over. And we will fire this guy up. Finally. And there it goes. It's homing. As I said, it homes to the top. It'll hit the limit switch, and then it will pretty slowly lower back down. And now we are in 5 times speed. So could get a little jittery in here, but we are going to crank through this real quick. You can see my first layer is going down pretty nicely there. Very pleased with that. Now this, as I said, is their test print. This is the test dog. Things are at this point going pretty well. So I'm going to go ahead and skip ahead here.
And here you see it getting ready to finish up.
End of the print. A pretty nice test model. It's the same Cruelty dog that Cruelty does in most of their printers. A little bit smaller. It was about a 2.5 hour print on the machine. And, well, it said it was about a 2.5 hour print. It took about 2 hours, 45 minutes. So not much of a difference. Still relatively fast. And it is looking pretty good so far. So let's get a closer look at the quality of this model. Here we have our first test print from the ET4. Now this is one of 3 files that is included on the SD disk. It is the same dog that you get on most Cruelty models. It is smaller than the Cruelty version usually is. But this was the smallest test model on the initial card. So the nice thing about this is it told you that this is about a 2.5 hour print. There are 2 other prints in there that are 3.5 and 4.5 hours respectively. I went with the shortest one because I always try to do their test print, but I wanted to get to printing my own stuff right away as well. So we've been spending our time dialing in some of the settings to get as close as we can to this quality here. And as you can see, I haven't removed support from this yet, but our first attempt is not bad. It is a little rough, and if you look here, you can see the shell and infill interface is a little too broad. The infill itself is actually extending to the very tip of the shell and showing the pattern on the outside, and it is slightly hard to see, but it is raised up as well. So that was not ideal. We had to do away with that. So since we already had those 2 pieces printed, we switched to the Rook from the Egypt chess set. Now this is my Cura settings on the ET4. There is still a little bit of support left on here. Needs a little bit of cleaning, but as you can see, the infill problem was taken care of. My lines are straight. My curves are curved. Everything is pretty smooth, and I'm pretty happy with this. It will require a little bit of cleanup on these corners here, but I did run support up the side here to help with these graphics in here. So overall, very, very happy with the quality that this machine produces. Very, very happy with a lot of the stuff that's on this machine. I am looking forward to, as I said, diving into those bells and whistles, and we'll talk about those in the review in the coming weeks. Stay tuned. We're going to have a lot of this printer coming up. If you saw my video about the connection in the other printer that's not quite working correctly, we're going to be taking that apart and working on that as well, because I really, really like this machine, and I would like the other one to be working. And it's one of those things where obviously I'm not going to leave it running while there is a known electrical problem, but I should be able to follow all the lines and ensure that everything is connected properly. And I think my only option at this point is to open up the power supply and see what's going on in there, because that's the only connection I haven't actually checked yet, and it seems to me that that is where this is all stemming from. So this ET4, however, the one that turns on and runs amazingly well. It works great. I will say there are a few things that are different about this machine that we will also go into on the review, such as the fact that it homes to the top of the Z-axis, which is interesting. So when you print a model, it will always raise all the way to the top, and then it really slowly and accurately lowers itself back down to get to the proper position. So starting a print is a slightly different process. The procedure is still the same, where you basically select the file you want to print and hit your print button, but when the printer actually kicks on and starts its process, it is a little bit different than most of the ones that you see. So it was interesting to watch it run. I've had a lot of fun playing around with this, and we are going to get back to work on that review right now. So if you like this video, guys, leave a like down below. don't hesitate if you get the chance to try one of these out to give it a shot. I'm not going to give an official review on it just yet because I want to put it through its paces, of course, obviously. But you can't really argue with that quality. I mean, it looks great. And obviously, being my second attempt at a profile, we have a little bit more tweaking left to go. But I am not unhappy with this model at all. This is a very, very functional and well-produced piece. As I said, it does need a little bit of cleanup, but overall, I'm very pleased.
As always, this channel is brought to you by these fine Patreon supporters. If you'd like to support the channel on Patreon, head over to www.patreon.com/Technivorous.
That's going to be it for this video. As always, I am Technivorous, and thanks for watching. Don't forget to check out our main channel page where we do a free giveaway for our subscribers every month. So far, we've given away things like a Capricorn PTFE tubing kit and spools of filament. So the giveaway videos are always pinned to our main channel page. So all you have to do is subscribe and leave a comment on the giveaway video for the current contest. Feel free to check out this video right here. YouTube picked it from my content just for you. And if you haven't already, you can hit the subscribe button right here. So what are you waiting for? Become a Technivore now. Thanks again. Technivorous out.